This lesson is on arithmetic sequences. Now we've been doing a lot with graphing and different formulas for algebra. This is going to take a step into describing lists of numbers, calling them a sequence, and specifically an arithmetic sequence and what formulas we can work with in those sequences. So first of all, we need to talk about some of the terminology. A sequence is a list of numbers. So we've got a couple examples here in your notes. This is a list of numbers, this is a list of numbers. Now what sets them apart is what we call an arithmetic sequence. An arithmetic sequence is when you add the same thing on each time to get to the next term. So as an example here, notice that we're going to be adding 11 on to get to the next term 16, and we still keep adding 11 to get to the next term 27, and then we add 11 on to get to the term 38. So an arithmetic sequence is you add the same number to get to the next term. So the key words are you're going to add, and it's going to be the same number when you do that. Now, let's talk about this example then, and we'll do this example here just to describe it. If you look at this example, we're going to call this the first term a sub 1. So we're going to describe terms using letters with a subscript. Now you're used to superscripts like having something squared or cubed, but we're going to use subscript, meaning this number is going to be just a little bit below it to say which term in the sequence is it. This is the first term, this is the second term, this is the third term, and this is the fourth term. We want to see if we can predict what the next terms, the fifth and the sixth terms, are going to be in the sequence. So if you want to do the next two terms, let's say that we want a sub 5. A sub 5 is going to equal that a sub 4 plus 11. A sub 4 is equal to 38. You're just going to add 11 onto it, and you're going to get 49 for it. Now that's a lot of work. Really all you have to do is say that 38 plus 11 is 49. But this will help us understand some of the notation that I'm going to use. A sub 6 is a sub 5 plus 11, which if you take 49 plus 11, you get 60. So the next two terms in the sequence are 49 and 60. Let's go ahead and see if we can describe that with example 2 here. Again, this is our first term, our second term, our third term, our fourth term, and I actually give you the fifth term in this one. So what are we adding on each time to get to the next one? Well, you might look at that and say, wait, we're going down in numbers, so looks like we're subtracting. Well, we can describe that as adding a negative. To get from 12 to 7, we're going to add negative 5. To get from 7 to 2, we're going to add negative 5. So you just keep adding negative 5 on it each time, and you get to the next term. So what we've got here then for this is, if we're going to find the sixth term, we're going to take the fifth term, and we're going to add negative 5 onto it. So that's going to be negative 8 plus negative 5, and that gives me negative 13. Same thing for a sub 7. I'm going to take the sixth term, I'm going to add negative 5 onto it, and negative 13 plus negative 5 gives me negative 18 for that term. So what's really important to describe these is to know what the first term is and what it is we're adding on each time. So I'm going to give go ahead and state that with this one. This is we want the first term, which is, we're gonna say is the a sub 1 term each time, so a sub 1 and a sub 1 there. And then we're gonna call the common difference for each of these. We're going to call that D. So here the D would be -5. Here the D would be 11. That's the thing we're adding on each time, common difference to get to the next term. So a recursive formula for this, is builds on this idea of if you know the first term and the common difference, you're going to be able to come up with a formula for it. So this is based on what do you add to get to the next term. That's the question we're asking with the recursive formula. What do you add to get to the next term? How we list it looks like this. So this is a new notation for you. We're going to list it. It looks kind of like how we did with the piecewise functions. Because there's two pieces of information, we need two pieces to the formula. You need to define what is the first term to it. So this here, go ahead and label this. This is our first term. So we do put a little notation here. We say when n equals 1, because this is what we use for the first term. And then to get to the next one, remember what we did here? To get to the 5th term, we use the 4th term. To get to the 6th term, we use the 5th term. It's always one less than it. So to get to the nth term, we use the n minus 1 term, one less than it, and we add the common difference for n greater than 1. This is called here, this is the common difference. Those are the two pieces of information you need to describe it. Where do you start? What's the first term? And what do you add on each time? So really we're filling in a sub 1 and d each time. So let's do that with these two examples here. All right, so for this example, example 1, what I'm going to do is write out my formula. My formula is a sub n equals, and I'm going to fill in what the first term is for n equals 1, and then I'm going to take the previous term, a sub n minus 1, and add the common difference for n greater than 1. So those are the formula is always going to look like this, just filling in those two blanks. Those two blanks, I know what the first term is here. The first term is 5, and my common difference is 11. So this is the recursive formula. It tells me start with 5, add 11 to get to the next term. Let's do the same thing for example 2. Okay, so for example 2 here, we're going to go ahead and write out our formula. A sub n equals 2 levels to it. We're going to list the first term for n equals 1, and we're going to list a sub n minus 1 plus whatever the common difference is for n greater than 1 for every term after the first one. So if we look at that, we're going to go ahead and say, well, we started with 12. And then we add each time a -5 on. So that fills in the blank for what we have for the recursive formula. Okay? Now the problem that we're gonna have with these is what happens if you want, this is nice for like 7, 8, 9, 10th term. What if you wanna know the 90th term or the 1000th term? You don't wanna just keep adding -5 on to get out there. So what we wanna do is come up with a new formula, a new way to do that, called the explicit formula. The explicit formula, this is when you want to jump to a term, go down the line a little bit. So you use this to jump to a term further down in the sequence. All right, now let's just talk through what's happened here and how we come up with this formula. Think about this one here. To get to the 4th term of example 1 here, I started with 5, I added 11 once, I added 11 twice, and I added 11 3 times. Okay, to get to, let's say, this -8, I started with 12. Okay, this is the 1, 2, 3, 4, 5th term. So I started with 12, I added -5 once, I added -5 twice, I added -5 3 times, I added -5 4 times until I got to that -8. You're always adding that common difference 1 less than it because we didn't add -5 to get to the 12. We started with 12, and to get to the 2nd term we added -5 once. To get to the 3rd term we added -5 a 2nd time. So that's why in this explicit formula, what we're going to do is take advantage of that it's always 1 less than it. And our formula will be a sub n equals, you got to start with the first term, a sub 1, and then you're always 1 less than it. If this is 12, you're going to do 12 minus 1 is 11, and you're going to multiply it by the common difference. All right, so as an example here, let's go ahead and do our examples up here. Let's do example 1. So the explicit formula for the one up here, for these numbers, okay, you need to know the first term and what you add on each time. That's the key idea. So what we're going to do is we're going to have a sub n equals, and you fill in the first term. The first term for it was 5, and then we're going to take n minus 1 times d, fill that in, and my common difference was 11. So let's say you want to find a sub, let's say 40. I'm going to find the 40th term in this sequence. Well, you'd have to add on 11 a lot of times to get there, or just use this explicit formula. 5 plus what's 1 less than 40, that's 39, and then multiply by 11. So let's do that on our calculator. Okay, so let's turn this on here. We're going to clear this off. And so we're going to take 5 plus 39 times 11. And we get an answer of 434. The nice way to jump to that 40th term is to just use this formula. Let's do example 2. Example 2, we're going to write out our explicit formula. You're going to have the first term plus n minus 1 times the common difference. We have to fill in those two numbers. Well, the first term was 12. The common difference was -5. If you want to put that in parentheses, you can. All right, so what if we want to find out what is the 950th term? 950th term. So what we'll do is we'll start with the 12, and we'll add to it. What's 1 less than 950? Well, it's 949 times the -5. Let's do that on our calculator. So we'll clear this off. We'll do 12 plus 949 times, and then we'll put a -5 in there. And I get for an answer -4,733. So the advantage of the explicit formula is it allows us to jump in an arithmetic sequence all the way to whatever term we want. The advantage of the recursive formula is it tells you to get to the next term, what are you doing each time? But specifically, this is for arithmetic sequences. Arithmetic sequences are when we add the same number on each time to get to the next number in the sequence.